Somewhere in the darkness of space, there's a planet staring back at us. Not metaphorically, literally. A world with a massive glowing eye stretched across its surface, watching the cosmos with an unblinking gaze that has remained fixed for billions of years. Scientists call them eyeball planets, and they might be our best chance of finding alien life. Right now, orbiting distant red dwarf stars, there are worlds locked in an eternal stare. One side forever burning under an endless day, the other frozen in perpetual night. And between these extremes, a ring of twilight where temperatures might be just right, where water could flow, where life could exist. These planets don't spin like Earth. They're gravitationally shackled to their stars, presenting the same face forward for eternity, creating one of the most bizarre planetary configurations we've ever discovered. The image is haunting. From space, these worlds would appear as cosmic eyes peering into the void. A bright iris of scorched rock or reflective ice staring outward. A pupil of eternal darkness at the center, and around it all, a thin band where day meets night, a terminator zone that could harbor ecosystems unlike anything we've ever imagined. But the strangest part, we found dozens of them, and the more we look, the more we find, suggesting that eyeball planets might be among the most common worlds in the galaxy. For decades, we searched for Earth-like planets orbiting sun-like stars. We imagined alien worlds spinning through their days and nights with seasons, weather patterns, and familiar rhythms. We were looking in the wrong places. The universe had something far stranger waiting for us. Something that challenges everything we thought we knew about where life can exist. To understand these bizarre worlds and why they might be teeming with life, we must journey back to the moment astronomers first realized that the galaxy's most common stars create the galaxy's most alien planets. The story begins not with a discovery, but with a realization that changed astrobiology forever. For most of human history, we could only study one solar system, our own. The sun seemed like the standard template, yellow, medium-sized, stable, the kind of star that sensible planets orbit. Then in the 1990s, we started finding exoplanets, worlds orbiting other stars. And slowly, a troubling pattern emerged. The universe wasn't following our expectations. Red dwarfs, the small, dim stars that make up 70% of all stars in the Milky Way, had been largely ignored in the search for habitable worlds. They seemed too faint, too cool, too prone to violent stellar flares. But by the early 2000s, astronomers realized they'd made a critical oversight. Red dwarfs might be dim, but they burn for trillions of years. They're the longest-lived stars in the universe, and planets orbiting them are close enough that even modest telescopes can detect them. In 2007, the first potentially habitable planet around Terre, a red dwarf was discovered, Gliese 581d, a world orbiting in its star's habitable zone where temperatures could support liquid water. But there was a problem. Calculations showed that at such close distances, the planet would become tidally locked, just like Earth's moon always shows us the same face. One hemisphere would roast under constant starlight, the other would freeze in endless darkness. Most scientists assumed such worlds would be lifeless wastelands. Then came the simulations. In 2011, researchers at the Institut Pierre-Simon Laplace in Paris ran the first detailed climate models of tidally locked planets. What they found shocked the scientific community. Instead of dead worlds, the simulation showed something remarkable. Heat from the day side would circulate through the atmosphere to the night side. The frozen dark hemisphere would moderate the scorching hot one. And in between, in the twilight band where the star hangs forever at the horizon, temperatures could remain stable. Water could exist. Life could emerge. The models revealed an alien ecology. Imagine standing on the twilight ring of an eyeball planet. Behind you, the star sits motionless at the horizon, neither rising nor setting, casting everything in eternal amber twilight. Before you, the landscape gradually darkens into frozen blackness. Powerful winds howl constantly, driven by the temperature difference between the hemispheres. Storms rage in patterns that never change, atmospheric rivers flowing in eternal circuits. It's nothing like Earth, but it could be habitable. By 2013, NASA's Kepler Space Telescope was finding tidally locked planets by the dozens. Kepler 186f, roughly Earth-sized, orbiting in the habitable zone of its red dwarf star. Kepler 442b, even more promising, with conditions that might be more suitable for life than Earth itself. Then Proxima Centauri b, orbiting the closest star to our solar system, just 4 light-years away. A tidally locked world that might have oceans in its twilight zone. The evidence was mounting. These eyeball planets weren't rare curiosities. They were everywhere. The term eyeball planet emerged from scientific papers around 2013, coined by researchers trying to visualize these bizarre worlds. The appearance depends on what covers the surface. An ocean world would have a massive circular area of open water on the day side, surrounded by ice sheets extending into the night side. The liquid ocean acts as the bright iris. The surrounding ice forms the white of the eye. And from above, the resemblance is uncanny. A planetary eye staring into space. But there's another type, ice worlds, where the day side receives just enough heat to melt a circular region of ice while the rest of the planet remains frozen. Here, the eye appears inverted, a bright reflective iris of ice or snow on the day side, surrounded by the darker landscape of the night hemisphere. Both configurations create the same eerie impression, something watching, something aware. Of course, these are just patterns created by physics and orbital mechanics, but the human mind can't help but see intelligence in that unblinking gaze. The physics of tidal locking explains why these planets look the way they do. When a planet orbits close to its star, gravitational forces stretch it slightly, creating tidal bulges. Over millions of years, these forces slow the planet's rotation. Eventually, the rotation period matches the orbital period. The planet becomes locked, one face always pointing toward the star. Earth's moon went through this process long ago. Now it's locked to Earth, hiding its far side from our view. For planets orbiting red dwarfs, the process happens quickly, geologically speaking. Within a few 100 million years, they're locked in place forever. This creates the eyeball effect through a simple process. The star pumps energy into one hemisphere continuously. Depending on the planet's atmosphere and surface composition, this creates different patterns. With a thick atmosphere, heat distributes somewhat evenly, creating a hot spot directly under the star, the bright iris. Without much atmosphere, the day side can become scorchingly hot, while the night side freezes solid. The transition zone between these extremes, the twilight ring, becomes the most interesting region, neither too hot nor too cold. The Goldilocks zone wrapped around an entire planet. Then came the James Webb Space Telescope. Launched in 2021, Webb gave astronomers unprecedented ability to study exoplanet atmospheres. In 2023, researchers used Webb to observe LHS 3844b, a rocky planet tidally locked to its red dwarf star. The observations confirmed what models predicted. The day side reaches temperatures over 1,000 degrees Fahrenheit. The night side is hundreds of degrees colder. And the terminator zone, that twilight ring, shows evidence of temperature gradients that could allow for liquid water, at least in theory. More observations followed. TRAPPIST-1e, part of a system of 7 Earth-sized planets orbiting an ultra-cool red dwarf just 40 light-years away. Webb detected possible signs of an atmosphere, perhaps even water vapor. The planet is tidally locked, likely an eyeball world. If it has oceans, they would be concentrated in the day-side iris, with ice sheets extending into darkness. The terminator zone could be a band of liquid water thousands of miles wide, circling the entire planet. An alien ocean with no shores, where the sun never moves, and storms trace the same paths for millions of years. But here's where it gets truly strange. The habitability models suggest these twilight zones might be better for life than Earth's varied environments. On Earth, life must adapt to changing seasons, day-night cycles, temperature swings. Eyeball planets offer stability, the same conditions unchanging for billions of years. Evolution would have time to optimize perfectly for those specific conditions. Life in the twilight zone wouldn't need to adapt to winter or summer, day or night. It would only need to thrive in eternal twilight. And given enough time, life finds a way. Scientists have begun modeling potential ecosystems. On an ocean eyeball planet, the day-side iris might be too warm for complex life, heated to near boiling by the unrelenting star. But currents would carry nutrients from the hot zone into the twilight ring, where temperatures drop to comfortable ranges. Here, photosynthetic organisms could thrive near the surface, absorbing the constant angled sunlight. Deeper in the twilight ocean, predators might hunt in the permanent dim light. And at the border with the night side where temperatures plunge, ice shelves would form, creating habitats unlike anything on Earth. A planetary ocean with no land, divided into climate zones not by latitude but by longitude, each band with its own ecology adapted to fixed conditions. Land-based eyeball planets offer even stranger possibilities. Imagine a rocky world with a thin atmosphere. The day side is a scorched desert, rocks heated until they glow dull red. The night side is a frozen wasteland, temperatures dropping to hundreds of degrees below zero. But in the twilight zone, temperatures hover around freezing. Water seeps from the day side as vapor, condenses in the twilight zone as rain or fog, and flows toward the night side where it freezes into glaciers. A hydrological cycle, but sideways instead of up and down. Life here would cluster in the twilight band, in a ring-shaped biosphere wrapping around the planet. Perhaps microbial mats coating wet rocks. Perhaps something more complex, adapted to the howling winds and eternal dim light. The possibility of life on these worlds is taken seriously by astrobiologists. In 2024, a major study published in the Astrophysical Journal analyzed the habitability potential of tidally locked planets. The conclusion was startling. Under certain conditions, eyeball planets might be more likely to harbor life than Earth-like worlds. The key is atmospheric circulation. With a thick enough atmosphere, heat from the day side would transport to the night side, moderating both extremes. The terminator zone would maintain stable temperatures for billions of years. And stability, the study argued, might be more important than variety for life's emergence and evolution. But there's a darker side to these worlds. Red dwarf stars are temperamental. They produce powerful stellar flares, bursts of radiation that could strip away a planet's atmosphere over time. A tidally locked planet offers no escape. Its day side is perpetually exposed, bombarded by radiation whenever the star erupts. Models suggest that only planets with strong magnetic fields could protect their atmospheres long enough for life to develop. And even then, the radiation would be intense. Life on an eyeball planet would need to be hardy, perhaps living underground or underwater, emerging only when conditions allowed. Some researchers have proposed an even more unsettling possibility. If life exists on these worlds, it might have evolved to perceive the universe very differently than we do. On Earth, the day-night cycle influenced the evolution of circadian rhythms, sleep patterns, predator-prey dynamics. But on an eyeball planet, there is no day-night cycle in the twilight zone. The star never moves. Time would be measured differently, perhaps by weather patterns, by the oscillations of atmospheric tides, by the slow drift of continents if the planet has plate tectonics. Alien life there might have no concept of days or years as we understand them. Their perception of time itself could be fundamentally alien. This raises profound questions about communication. If we detect signs of life on an eyeball planet, if we someday receive a signal from one of these staring worlds, how would we interpret it? Life shaped by eternal twilight, by unmoving stars, by environments so different from Earth that even basic assumptions might not apply. The challenge wouldn't just be language. It would be understanding a form of consciousness shaped by a planetary environment we can barely imagine. They would live on a world that watches the cosmos with an unblinking eye. Would they think of the universe as we do? Or would their perspective be as alien as their home world? Current technology can detect these planets and study their atmospheres, but we're still years away from finding definitive proof of life. The James Webb Space Telescope is powerful, but it can only analyze the combined light from a planet and its star, looking for chemical signatures that might indicate biology. Oxygen, methane, phosphine, combinations of gases that wouldn't exist together without life producing them. Several eyeball planets are on Webb's observation list. TRAPPIST-1e, Proxima Centauri b LHS 1140b, another promising candidate with possible ocean coverage in its day-side hemisphere. In 2023, Webb observed the TRAPPIST-1 system in unprecedented detail. The results were inconclusive but tantalizing. Some atmospheric signatures that could indicate water vapor, possible carbon dioxide, nothing definitive, but enough to keep scientists searching. The next generation of telescopes, planned for the 2030s, will have the sensitivity to detect biosignatures more clearly. The Habitable Worlds Observatory, proposed by NASA, would specifically target eyeball planets, analyzing their atmospheres for signs of life. If life exists in those twilight zones, we'll know within the next few decades. But here's the unsettling truth. We might already be surrounded by eyeball planets teeming with life, and we wouldn't know. Red dwarfs are everywhere. Planets orbiting in their habitable zones are common. Tidal locking is almost inevitable at those distances. That means eyeball planets might outnumber Earth-like worlds by a significant margin. The galaxy could be full of them. Worlds with single, staring eyes, scattered throughout the spiral arms, watching the universe with eternal vigilance. And if life is common on such worlds, then we might be the unusual ones. Life on a spinning planet with day and night cycles might be the exception, not the rule. This changes everything we thought we understood about habitability. For decades, we searched for Earth 2.0, a perfect copy of our world orbiting a sun-like star. We wanted familiar conditions, reassuring similarities. But the universe doesn't care about our comfort. It produces what physics allows. And physics allows tidally locked worlds to exist in vast numbers, each one potentially harboring life in its twilight zone. The implications are staggering. If eyeball planets are habitable, then the universe might be far more crowded with life than we ever imagined. Not in places that look like home, but in places that look like nightmares. Worlds locked in eternal stares, their surfaces divided into zones of fire and ice, with only a narrow band where life clings to existence. And perhaps that's the final, most humbling lesson of the eyeball planets. Life doesn't need paradise. It doesn't need Earth's gentle cycles, its comfortable temperatures, its familiar rhythms. Life needs stability, energy, and liquid water. Eyeball planets can provide all three. In the twilight zones of these bizarre worlds, evolution has billions of years to work with the same stable conditions. What might emerge from such environments? Complex ecosystems adapted to eternal winds and fixed sunlight? Intelligent species that never developed concepts of sunrise or sunset? Civilizations that measure time by the pulse of their stars' flares instead of by planetary rotation? We don't know yet, but we're looking. Every new exoplanet discovered, every atmosphere analyzed, every simulation run brings us closer to understanding these alien worlds. The eyeball planets are out there, scattered throughout the galaxy, their great cosmic eyes staring into the darkness. Some might be dead, their atmospheres stripped away by stellar radiation. Others might be thriving, their twilight zones filled with alien oceans and strange life forms. And a few, perhaps, might be looking back at us. Not with consciousness, but with the same unblinking gaze they've maintained since their formation, a gaze that will continue for trillions of years, long after humanity is gone. Because in the end, the universe doesn't blink. It watches. It waits. And somewhere out there on a world locked in eternal twilight, life might be doing the same. The eyeball planets are watching the cosmos, and the greatest mystery still remains. Are they watching alone? Or is something staring back from within those twilight zones, aware of its own strange existence, wondering if anything else is out there? The answer might be closer than we think, but it won't come from Earth-like worlds orbiting sun-like stars. It will come from the places we least expected, from the planets that stare, from the eyes in the darkness, from the worlds that never blink.